So I wanted to actually go through your final exam, practice exam, just your practice exam, sorry, and just give you some video solutions to help you out. So first, we have the situation of a car accelerating from this speed to this speed in a time of 10 seconds, and that's actually velocity. So we're actually speeding up, and I want to label our axes. So we got 2, 4, 6, 8, and 10 seconds on our axes. And then we're going to actually go here, so we have 20 meters per second, and then we got 40 meters per second. And so what I want to do is I want to go ahead and actually label my graph with the proper plot. And let's be clear here, this means we're going to actually start at 10 meters per second, and we're going to go all the way up to 50 meters per second like this. So if I were to actually plot this, let's kind of be careful. We go from 10 all the way up to 50. It's the velocity graph, so we're actually dealing with the straight line graph like this. So that's what that plot looks like. Now we want to determine the acceleration of the car, and the way we're going to do that is that we're going to actually use the formula. Well, let's remember, the initial velocity is 10 meters per second. The final velocity is 50 meters per second. We have a time. We don't know the acceleration. We know the initial position is 0, or we assume it's 0 because they haven't given it to us. We don't know the final, so when we plug in, the only formula that we can really use is this guy. And so we're going to actually have that 50 equals a times 10 seconds plus 10, and a actually ends up being 4 meters per second squared. Now we want to know how fast the car is going 4 seconds after it starts. So we want to know the final speed at 4 seconds. Now one thing you could do is you could try to read it off here, and you realize it's somewhere between 20 and 30 meters per second. So from the graph, you might guess, oh, about 25, 26 meters per second. But we can do better than that. We can do v equals at plus v naught, and we can plug in v. We can solve for v by plugging in 4 for acceleration and 4 for time, and we have an initial velocity of 10 meters per second. So we end up getting v is 26 meters per second. So that's actually pretty good. So if we kind of continue with this problem, we want to know how far does a car travel during the entire 10-second time. It's weird. So we're going to get x equals 1/2 at squared plus v naught t plus x naught. And then we plug in our numbers. We're going to get x equals 1/2 times 4 times 10 squared plus 10 times 10. And that gives us 300 meters. There's another formula that's actually in the PDF file, but what I wanted to show you was another method, which is that if I want to get the displacement, another way to get this is I can actually get the area under this graph. I'm just going to show you that on this thing because you may not need to do it on the exam. But here, I'm going to do 1/2 base times height. So I'm going to do 1/2 times, I've got a base of 10 and I've got a height of 40, plus this area at the bottom, which is going to be 10 times 10, which is 100. And when we actually calculate this, we end up actually getting 300 meters that way. So that's the second method. So that's E2 method. But if that's a little confusing, I would just stick to the method in part A. So hopefully that clears it up for you. And if you're having a little trouble reading this, I would look at the PDF solution file to kind of get you through that. So that's problem number 1. In the next video, we'll do problem number 2.